we're looking at how to find area of a region between two curves. That's the region between between curves. This is under integrations, and if you look at the curve we have two graphs. We have the first one, which is what y equal to f of x. That's the upper curve, and we have the lower curve. Okay, y is equal to what, g of x. So in this kind of aspect, using integration to find area between two curves. One of the things we're going to do is to find the point of intersection of those the two graphs. And in this case now, the point of intersection is what is assumed to be A and B. Okay, that's your A and B. That's where the two graphs intersect. And the enclosure, that's the area we want to find using the integral. Okay, so, and we said that suppose that f and g are continuous functions with we assume f of x is assumed to be what? That's the upper curve is greater or equal to g of x on the interval. The intervals are your point of intersection. Okay, so you can find the area of the region bounded by the graphs of f of x and g of x on that intersection by this formula. It's very simple. It's going to be your point of intersection is from A, that's the lower limit, to the what? To the upper limits, where the lower limits, the upper limits. And the formula is the upper curve minus what? The lower curve. Then you close your brackets. And that's that on how to find area of area of regions between two curves using integrations. So let's look at the practical questions to buttress to explain this.